Welcome to section 1.3. In this box here, I've got the definitions of the 6 trig functions, and they correspond to this picture over here, and you should be familiar with those. And you should also be able to fill out all the values on the unit circle. So on the last page of these notes, I've got a blank unit circle, and you should be able to go and fill in all of these angles and then fill in the corresponding points, the coordinates of the corresponding points. And I've got the key online in practice sheets, which is in the lecture notes folder. Okay, so one way to help you with that is the reference triangles. I do all my reference triangles with hypotenuse 1. And so for pi over 6, the short side is over here. The short side is a half. And the long side is root 3 over 2. For pi over 3, it just flips. The long side is opposite, root 3 over 2, and the short side is the adjacent side. And then for pi over 4, the opposite and adjacent sides are both 1 over root 2. And if you like to rationalize, that's the same as root 2 over 2. And then I've got a comment here on forming reference triangles, also a comment on tangent theta, and I'll talk about that in a minute. So for example, let's sketch 5 pi over 6 and its reference triangle in the unit circle. So we've got a unit circle here. That means radius 1. 5 pi over 6 is here. If I drop a perpendicular down to the x-axis, that makes my reference triangle. And I can see my reference triangle is pi over 6. So the short side is a half, and the adjacent side is root 3 over 2, but I'm going to write negative root 3 over 2 because that's the x-coordinate, and I'm in quadrant 2. So the coordinates of this point would be negative root 3 over 2, comma, 1/2. All right, the great thing about working on a unit circle is that these definitions simplify. Sine theta is y over r. Well, if r is 1, sine theta is just y, and cosine theta would be just x. So back to my picture here, cos 5 pi over 6 is going to be the x-coordinate, so negative root 3 over 2. Tangent 5 pi over 6. The long way is think of it as y over x, 1/2 over negative root 3 over 2, which is negative 1 over root 3. The short way for tangent is to think of tangent as the slope of the terminal side of the angle. That would mean the slope of this line right here. Now the slopes, let me just do this in quadrant 1. The slopes are going to be, for pi over 6, the slopes are gradual, 1 over root 3. For pi over 4, the slope is 1 to 1, so m is 1. And for pi over 3, the slope is steep, m is root 3. So tangent of any angle from our unit circle chart is either going to be plus or minus root 3, 1, or 1 over root 3, unless it's 0 or undefined. You don't have to do that. I'm just giving you options for how to compute tangent. Okay, next one. Given cosine is negative 4 over 5 and theta's in quadrant 2, make a sketch and find tangent and sine. All right, cosine theta is x over r. So I need to put the negative with the 4 because r is always positive. So now I know x is negative 4 and r is 5. So I draw a triangle in quadrant 2. So this would be theta. The x-coordinate is negative 4 and r is 5. Think of this as, if you want, lying in a circle of radius 5. So we need to fill in the missing side. Let's call that y. We could use Pythagorean theorem. Y squared plus negative 4 squared is 5 squared. So that's y squared plus 16 is 25. So y squared is 9. So y is plus or minus 3. All right, well, I'm in quadrant 2, so I know y is positive. So I'm going to erase this and put a 3. That's all I need to fill in tangent theta and sine theta. So let's do sine first. Sine theta is y over r, 3 over 5. Tangent theta is y over x, so that's negative 3/4. Okay, the next page is really just reference for you. I've got the graphs of the 6 trig functions. You should definitely know by heart the top 3, and the bottom 3 we don't use as much. For identities, These are the identities you have to know, except for this one. You don't need to memorize this one. And actually, this one is not on the identities you have to know in that sheet in the practice worksheet folder. But the inverse trig function values is on that list, and you should definitely take a look at that, and we'll work with that in the next section. All right, the Pythagorean identities. The biggest one is cosine squared plus sine squared equals 1. And then if we divide both sides of this equation by sine squared, we get 1 plus cotangent squared theta is cosecant squared theta. And if we divide both sides of this equation by cosine squared, then we get tangent squared theta plus 1 is secant squared theta. All right, even odd double angle. So the double angles that we use the most are these. And then the half angle we use a lot. For cosine squared, it's 1/2 plus 1/2 cos 2 theta. And then sine squared is the same, except there's a minus in there. And we use those quite a bit. And the Pythagorean ones we use quite a bit. All right, so let's solve some equations. Let's start with this one. Sine 2x minus cos x equals 1. So the first thing we need to do is get the arguments the same. This is a 2x and that's an x. So I'm going to use the double angle. Sine of 2x is 2 sine x cos x. And I subtract cos x and I get 0. Okay, now all my angles are x. I can factor out a cosine x and I get 2 sine x minus 1 in parentheses, and that equals 0. You need to keep carrying down the equal 0. And so this gives me two options. Either cos x is equal to 0 or 2 sine x minus 1 is equal to 0. And if that's the case, then sine x would be 1/2. So I'm solving two simple equations. So I'll put or here. And I can do those using the unit circle. I know cos x equals 0 when x is pi over 2 or 3 pi over 2. And sine x equals 1/2. Let me just draw a little unit circle here. Sine, on a unit circle, sine is the y coordinate. So that will be 1/2 at pi over 6 and at 5 pi over 6. So it all boils down to, do you know your unit circle? Okay, next one, I need another identity because here I've got cos and here I've got sine. I'd like everything in terms of one trig function. So you can use the Pythagorean identity that sine squared theta plus cosine squared theta equals 1 to write this equation as 3 cos theta plus 3 equals twice, parentheses. I can replace sine squared with 1 minus cosine squared and then distribute that 2. And now let's move everything over to the left. So 2 cosine squared theta plus 3 cos theta plus 1 is 0. And now I want to factor. So I can use guess and check. I know I'm going to need a 2 cos theta here and a cos theta here. And then to get a positive 1 at the end, there's only two options, -1 and -1 or +1 and +1. So let's try this. Does this work? When I FOIL this out, is the middle term 3 cos theta? And yes, it is. So this is good factorization. And so from here, I can say, okay, 2 cos theta plus 1 is 0, or cos theta plus 1 is 0. Now, you can skip this step. I like to jump to, right from here, I can jump to, in my head, cos theta is -1/2, or cos theta is -1. So this middle step, you can include or not include, depending on whether it helps you or not. If you can do it in your head, I'm fine with that. All right, again, we're down to unit circle. Cosine is the x coordinate on a unit circle, so that's going to be -1/2 here at 2 pi over 3, and here at 4 pi over 3. So I get theta equals 2 pi over 3, 4 pi over 3, and then cos theta equals -1 at pi. All right, and that does it, and that is the end of this section.